we will cover a topic about early fasting state. What is the meaning of early fasting state? Early fasting, or also known as post-absorptive state, is actually one of the state in the fed cycle that is occur during 3 hours to 12 hours following meal. What is actually happen when we do not eat or fasting? How our body gonna generate enough energy for daily activity? Our body tissues can no longer derive their energy directly from the ingested glucose and other ingested nutrients. Amazingly, our body depend on other sources in order to generate energy. During this state, which 3 to 12 hours after meal, hepatic glycogenolysis serves as the major provider of glucose. They are responsible to deliver glucose to the other body tissues for use as fuel. Glycogenolysis is actually a process which glycogen, primary carbohydrates, that are stored in the liver and muscle cells of animals, is broken down into glucose to provide immediate and to maintain glucose level in the blood during fasting. During glycogenolysis, synthesis of glycogen and triacylglycerols in liver diminished. Meanwhile, synthesis of glucose, gluconeogenesis, begins to help maintain blood glucose levels. The blood glucose level begins to drop several hours after a meal, leading to a decrease in insulin secretion and a rise in glucagon secretion. Glucagon is secreted by the alpha cells of the pancreas in response to a low blood sugar level in the fasting state. Just as insulin signals the fed state, glucagon signals the starved state, as it serves to mobilize glycogen stores when there is no dietary intake of glucose. After all, the most important thing is the main target organ of glucagon is the liver. Lactate is formed in and released by red blood cells and muscle tissue. It is an important carbon source for hepatic gluconeogenesis. Carbon in the form of alanine returns to the liver from muscle cells is called glucosalanine cycle. The first step in gluconeogenic conversion of alanine in the liver occur when alanine is converted to pyruvate. In the muscle, alanine cannot be converted to glucose. In post-absorptive state, glucose provided to the muscle by the liver comes primarily from recycling of lactate and alanine, and to a lesser extent from hepatic glycogenolysis. Muscle glycogenolysis provides glucose as fuel only for muscle cells in which the glycogen is stored. It is because muscle cells lacks of enzyme glucose 6-phosphatase. Once phosphorylated in the muscle, glucose is trapped there while 3 carbon units of lactate or alanine leave the muscle. The entry of glucose into muscle and adipose tissue decreases. In response to a low insulin level, the diminished utilization of glucose by muscle and adipose tissue also contributes to the maintenance of the blood glucose level. The net result of these actions of glucagon is to markedly increase the release of glucose by the liver. Thus, the blood glucose level is kept at or above 80 mg per deciliter by 3 major factors: 1. The mobilization of glycogen and the release of glucose by the liver; 2. The release of fatty acids by adipose tissue; and 3. The shift in the fuel used from glucose to fatty acids by muscle and the liver. So, what the extravagant consumers of glucose? They are brain and also other tissues of the central nervous system, or called as CNS. Both of them are oxidizing the glucose for energy. The brain oxidizes glucose completely to carbon dioxide and water. Thus, for the net synthesis of glucose to occur, another source of carbons is required. Glycerol released from adipose tissue on lipolysis provides some of the carbons, with the remaining carbons coming from the hydrolysis of muscle proteins. And they are releasing no gluconeogenic precursors in return. Here are the examples of gluconeogenic precursor. During gluconeogenesis, the rate of glucose use is greater than the rate of glucose production. And also through this process, the stores of liver glycogen begin to diminish rapidly. Gluconeogenesis from lactate and alanine continues, but this process merely replaces glucose that had already been converted into lactate and alanine by the peripheral tissues. In the course of an overnight fast, nearly all reserves of liver glycogen and most muscle glycogen have been depleted. Last but not least, we would like to express our gratitude towards everyone who play an important role in the process to complete this video assignment. Here are our references. Thanks for watching.